Ho! Yes! And welcome to our college algebra notes for 4.2, the properties of logarithms. Now, the properties of logarithms are used predominantly when we are expanding or condensing logarithms. And what that means is if we want to expand a logarithm, we want to take one logarithm and make it multiple. If we want to condense, we want to take multiple logarithms and make it one. And we'll talk about that more in detail. In order to do this, there are the three properties of logarithms that you need to know. The first one, multiplication. Now, multiplication says if we are multiplying, it's based off the law of exponents. If we're multiplying terms with like bases, we add the exponents. Well, in logs, that means if we are multiplying in the argument of a log, we can split it to two addition, right? Multiplying becomes adding, multiplying becomes adding. And here's an example here. The log of 4n is the same as the log of 4 plus the log of n. Then we have division. You can show we know that property. Division of exponents, b to the a divided by b to the c, this becomes subtraction, b to the a minus c. Same idea with logarithms here. Log of a divided by c becomes the log of a minus c. Now notice it says numerator minus denominator. So our example here, log of 7/5 equals log of 7 minus log of 5. Exponential, the third rule you need to know, is that if we have b to the h to the k, that's the same as b to the hk. Power of a power becomes multiplying in the exponent. So that idea here, remember logarithms are solving for exponents, so I can multiply. If I have log of hk, I can say that's k times the log of h. I can multiply that log by the exponent in the argument. So for example, log of 11 to the 4th would be 4 times the log of 11. So let me show you how this kind of works in context here. So here's an example of a condensing logarithm. So notice we start with multiple logs. We have 3 variables, and all sorts of things is happening to these variables. All right, so let's start with this 2 here. This 2 that we're multiplying by the log base 5 of m is going to become an exponent. The 3 that we're multiplying by the log base 5 of k is going to become an exponent. The 8 is going to become an exponent, all in the argument. Now notice a key thing here. A very important idea that we need to know is that all of these logs have the same base. If they don't have the same base, this doesn't work. They all have to have the same base. All right, so now notice those 2, 3, and 8 becomes our m squared, our k to the 3rd, and our y to the 8th. All right, now check this out. We are adding together 2 of these logs. All right, we are adding together log base 5 of m squared and log base 5 of k to the 3rd. So that means it becomes multiplication as one log. So log base 5 of m squared times k to the 3rd. Addition becomes multiplication. And lastly, notice that we are subtracting log base 5 y to the 8th. Okay, well what does subtraction become? Subtraction becomes division. So we're going to subtract y to the 8th. Well, that's the same as dividing in the argument, y to the 8th, okay? So that's how these properties can work. So where we started with 3 logarithms, 2 log base 5 of m, 3 log base 5 of k, 8 log base 5 of y, we start with 3, but we can end with 1 logarithm. All right, now that 1 logarithm, see how we still have all the variables we started with? The coefficients of the logarithms became exponents, and that base 5 stays the same for everything. All right, now that's an example of condensing logarithms. Now check out expanding logarithms. So it's the same idea, but we're going backwards here. If they ask us to expand, we want to split it into as many logarithms as appropriate. So we can start with this, where you're dividing by y to the 8th. Well, that's the same as subtracting. Dividing y to the 8th becomes subtracting log base 5 of y to the 8th. Now notice we're multiplying m squared and k to the 3rd. So that multiplication can become addition. We can split that up. All right, now what do we do with those exponents? Those exponents that we have in here, m squared, k to the 3rd, y to the 8th, those become the coefficients of the logarithms. So it's the same properties, we're just going the other way with them. All right. If you have any questions, feel free to raise your hand at this point. I'd be happy to come. Otherwise, let's look at a couple and do them together. So let's look at letter A here. 10 times log base 7 of u plus 5 times log base 7 of v. Well, first thing I see, I have numbers in front. I have these logs, coefficients, basically. Well, they're going to become exponents. So I'm going to say I have log base 7 of u to the 10th. I like to put that in parentheses, plus log base 7 of v to the 5th. All right. Now notice I'm adding. Well, if I'm adding logarithms, that means I can be multiplying in the argument. So I'm going to have log base 7 of u to the 10th times v to the 5th. And now I'm done. I can tell I'm done because I only have one logarithm and everything's simplified in that argument. There we go. Let's look at letter B as well. So I have 5 times the natural log of c plus the natural log of a over 3 minus the natural log of 12. So one thing I want to point out here, dividing by 3 is the same thing as multiplying by 1/3. So I want to rewrite this as 1/3 times the natural log of a, because I think that makes it a little more apparent what I'm going to have to do here. I know that this is going to become the natural log of c to the 5th. But what happens when I do a to the 1/3? What's another way to write that? That'd be a radical, right? The cube root of a. So this is going to become plus the natural log of the cube root of a. And then I'm going to subtract the natural log of 12. Okay, so if we're adding, that can become multiplying. So I'm going to have the natural log of c to the 5th times the cube root of a minus the natural log of 12. If I'm subtracting, that becomes division in the argument. So my final answer here is going to be the natural log of c to the 5th times the cube root of a divided by 12. And that's how we get that. All right, if you're feeling comfortable, go ahead and try C and D on your own. Otherwise, raise your hand, and I'll come explain anything further if necessary. Otherwise, try C and D on your own. Go ahead and pause the video, try C and D, and then we'll check it together. All right, let's go ahead and see how we did with letters C and D. So first, looking at letter C, we have 6 times log base 3 of x plus 2 times log base 3 of y minus 7 log base 3 of z. So let's go ahead and take care of all these coefficients first. So this is going to be log base 3 of x to the 6th plus log base 3 of y squared minus log base 3 of z to the 7th. And now from here, we're kind of similar to letter B. I'm adding together these, so I'm going to multiply in the argument. So log base 3 of x to the 6th y squared minus log base 3 of z to the 7th. If that kind of looks like a z, doesn't it? There we go. If I am subtracting logs, I can be dividing argument. So log base 3 of x to the 6th y squared divided by z to the 7th. And that right there would be my final answer. So that's letter C. Looking at letter D, let's see what we have here. All right, I see a fraction, so I'm going to go ahead and rewrite that. So I'm going to have 2 log base 6 of 7 plus 1/2 log base 6 of 12. Okay, so something to the 1/2. This is going to become 12 to the 1/2, which is going to become the square root of 12. Now, the square root of 12 I can simplify. That's going to become 2 root 3. No need for plus or minus here. Log, it's got to be positive, right? Argument has to be positive. So I'm going to say log base 6 of 7 squared. Let's see. Plus log base 6 of 2 root 3. Now if I'm multiplying, 7 squared is 49, all right? 49 times 2 is going to become 98, so this will become log base 6 of 98 root 3. Now if you didn't simplify that all the way, let's say you left it as like 7 squared times 2 to the root 3, go ahead and simplify that. If you have any questions over condensing, please just raise your hand. Happy to come around, answer questions. Otherwise, let's look at expanding logarithms, all right? So make sure we remember our properties here. So let's look at letter A. First thing, expand the logarithm, be sure we're fully expanded. What that means is that all of our logarithms, the only thing in the arguments are the variable. That should really be the only thing, or the number, the value. All right, we shouldn't have anything really else going on there. So with that being said, log base 7 of the quantity x over y squared. So the first thing I'm going to do is I'm actually going to apply this 4 into everything. So I'm going to turn this into log base 7 of x to the 4th over y to the 8th. And when I do that, that's going to now allow me to separate this out a little bit easier. So division means subtraction. So I'm going to have log base 7 of x to the 4th minus log base 7 of y to the 8th. Now what happens to these exponents? They become coefficients for the logarithm. So I'm going to have 4 times log base 7 of x minus 8 log base 7 of y. And I'm done. And how can I tell I'm done? Because the only thing in those arguments are my variables. Everything else is simplified out. And that's how we can identify that we're done. So let's look at letter B here. This one has numbers. So we know we're done when the only thing left is the value, okay? So notice here we have, this one's tough. I'm going to start by splitting this up. All of this is being multiplied. I could rewrite this as log base 3 of 5 times the cube root of 12 times the cube root of 7. And that might be a helpful first step because I see how many logarithms I'm going to have. I'm going to have 3. Now you could go ahead and multiply 12 times 7, but I think in this instance they really want us to split it all up. Otherwise they probably wouldn't have written it like this. So with that being said, let's go ahead and split this up. Multiplication means addition. So I'm going to have log base 3 of 5 plus log base 3 of the cube root of 12 plus log base 3 of the cube root of 7. So now these cube roots are going to go away. Now let's refer to what we did up above. When we had a cube root, it becomes over 3. So my final answer here is going to be log base 3 of 5 plus log base 3 of 12 over 3 plus log base 3 of 7 over 3. Notice the only thing in those arguments are the values. Everything's outside. We're looking good from there. All right, if you have any questions over expanding, please raise your hand. Happy to come around. Otherwise, why don't you go ahead and try C and D on your own. Go ahead and pause the video. Try C and D on your own. We'll see how we do. All right, let's check out how we did with C and D. So first thing I'm looking at letter C, log base 5. I see this to the 3rd, so I'm going to go ahead and push that 3 into everything. So I'm going to have log base 5 of x to the 6th times y to the 3rd times z to the 9th. Remember, power of power, we multiply. So now I see this multiplication occurring. That means addition. So I'm going to have log base 5 of x to the 6th plus log base 5 of y to the 3rd plus log base 5 of z to the 9th. Now these exponents I got to get rid of. They become the coefficients, so to speak, of these logarithms. So I'm going to say 6 times log base 5 of x plus 3 log base 5 of y plus 9 log base 5 of z. And that right there is letter C. I can tell I'm done because I only have those variables in my argument. Now looking at letter D, I see we're starting with some division in my argument, so that can become subtraction. So I'll have log base 8 of w to the 4th minus log base 8 of the square root of u. Okay. Well, the next thing I need to do, the square root of u is the same thing as u to the 1/2, right? Which we're going to write as a fraction. So we'll have log base 8 of w to the 4th minus 1/2 log base 8 of u. Now, again, same with what we did with letter B here. We're going to make that, instead of leaving it as 1/3, we're going to make it this fraction. We have 1/2, so we'll put it over 2. We need to move that 4 in front as well. So our final answer here will be 4 log base 8 of w minus log base 8 of u all over 2. It's important that we put that entire logarithm over that fraction, and that, my friends, is our final answer. All right, hopefully we're feeling confident. If you are, go ahead and start on the practice problems for 4.2. We can knock those out today probably as well. Mr. Carter, sign off. Happy to see you all again. If you have any questions, please don't hesitate to ask. I'll see you next time.